This is Lab 3, Magnetic Field of a Bar Magnet. The purpose of this lab is finding the correlation between the observable distance and magnetic fields. To do this, we're using the Biot-Savart law, which finds the magnetic fields with displacement and magnetic dipole moment. Skipping ahead, the results, the magnetic dipole moment was found to be 1.87 joules per Tesla for my specific magnet. The procedure of this lab was to first determine the direction of magnetic north, and to do this, I downloaded a magnetometer app from the App Store, and then I lied my phone flat and rotated until the x component became 0, and then I put a meter stick perpendicular to the north direction, and then I found the magnetometer on my phone, and then moved the phone at various distances along the meter stick from the magnet to the magnetometer, both on axis and at a 45-degree angle. Uh, the magnetic field is really just a function of mu, which is the magnetic dipole moment, and r, which is an observation vector. Both of those are parts of the Biot-Savart law in the top right corner that B is equal to. And then I'm assuming all of them are constants except for r. The magnetic field is pointing from south to north, and usually n is equal to -3, and we're gonna try to see if that's the case in this experiment. Uh, I took the After getting the measurements at various distances, I took the log. The computer gave me the logarithmic values for each of those, and it's going to generate a logarithmic plot to estimate r. And it takes the logarithmic value, so that way we can get a y equals mx plus b format. And here's the actual graph I got, and because it's a logarithmic value, it's a linear line, and my n was equal to -3.05, which is pretty close to -3, which was the essentially correct in quotation value. And my natural log of k was equal to -14.525. Uh, for the off-axis magnetic field, you put the phone distance perpendicular in x and y direction, and then you measure the magnetic field using the phone and the magnetometer. And so the average distance perpendicular was 0.17 meters. Uh, to find the off-axis estimate, we use GlowScript, and I've filled out the dipole B definite, like the function, and B is essentially just the Biot-Savart law, and GlowScript outputted a value of 6.38 times 10 to the -6, 1.91 times 10 to the -50 as the magnetic field vector. And so I defined various observation locations and calculated B at those locations and created 3D arrows. I have observation perpendicular and observation axis based on various distances, and took those and made a bunch of R axis, B axis, and a bunch of like 4 different arrows. And this was the glow script output. The magnet is in the center, and then you have magnetic field direction and the other 2 arrows. So if we hadn't oriented our experiment from the beginning to compensate for magnetic north, all the readings would be skewed toward the magnetic north, and the values would be less accurate as a result. Since we since we rotated the phone to magnetic north in the beginning, we didn't have to worry about the values being less accurate. And if we were to stick 2 identical magnets together end to end and run the experiment again, the direction of the field would be the same, but then the magnetic field would double as a result.